Finally time to get this liquid cooling unit from the G5 taken apart. Now I've already removed some of the pipe work and disconnected basically, well, most of the fittings, simply to drain out the unit. It had this very gnarly colored pink liquid in it, which well, was pretty easy to get out. And I did wire up the motor, well, both of them. There's two motors using this jury-rigged thing, and they do run. I don't know if you can hear that, but they are running. Oh, there's some of the liquid. And yeah, so let's start taking this stuff apart. I'm curious to see what everything looks like in there, like the design of the water block. And I'm mostly curious about this black channel thing behind or above the CPUs. So I think I'm basically just going to start taking out every single screw I can until we've got all the pieces of metal and plastic separated, because it's kind of awkward to work with this thing. And it also has the advantage of finding any spots that still have liquid in them. There's an end cap. Okay, I was hoping I could get away with using my larger screwdriver. There's an end cap that you can remove. This is it. And there's also a few other hinges. They all use this, or connections. They all use the same interesting clamps. Now, supposedly the clamps are good, but the O-rings they use aren't very good, and they're what leak on these models. Mine doesn't seem to have any O-rings on anything. I took apart most of the hoses, so I don't know where these O-rings are that people speak of, unless this is a revised model that no longer has the O-rings. Let me just snip the 4-wire connection to this. I think that should get rid of the wiring. Yeah. Alright, let's get all the wiring out of the way, including this adapter. No need to have this around. Okay, so there are these two big blocks that hold, or plates that hold the whole unit down to the CPU. So I get these guys out with these giant screws. It's all nice machined aluminum. Everything's very smooth, like there's no sharp edges. This is really, really nicely made, these things. There's one plate. Ooh, fancy. Very light too, thanks to it being aluminum. There's a little insulation thing here. That might actually be there just in case the metals are dissimilar, to prevent it from acting like a battery if it gets moist. They often do that with whenever you're dealing with metal. If you mix two different types, you can often create a battery which will then corrode very rapidly. If you've ever seen plumbing stuff where you're using copper, you'll see that the straps that hold the copper together, wow, this is really rusted and tough. I don't know why. Maybe it got wet when I was working on it. I don't know. But you'll see that even the straps holding the copper are copper, usually. Because, okay, that's not coming out. Maybe it can just snap off. Why do I have the feeling I'm going to hurt myself? It bent the aluminum a little bit. That's really in there. Let's get a grip on it. Oh, God. Yeah. I don't think that's going anywhere. Oh, wait. I spoke too soon. It turned. Barely. Oh, God. Yeah. Let's just take everything else off, because that is annoying. Ow. Okay, so there's some screws along the side here. Get as many of these out as I can, and hopefully the chassis around the Rad comes off, although, oh no, it should come off. It should come off. Yeah, there's this plastic block right here that I'm very interested in. Like, the topology of this thing seems to be that it goes through one CPU, then a little interconnect, this thing, with the lovely bent copper, going to the other CPU pump, and then it goes into this black mystery box, and then into the Rad. So I really don't know what that thing's doing. Now there's stuff on the top I should get off too. Oh, got a couple drops of water and a couple drops of the coolant. This is the top plate that has all the warnings and the part numbers and stuff on it. One problem with my current setup is that I'm kind of forced to turn everything with my right hand, and I'm left-handed, which is a little annoying. It means I strip more screws than I probably should. There we go, that's a bit better. Okay, so this should come off. Just a little wet. So here's the information on it. Manufactured by Panasonic, 12 volts. It's got the Apple part number and whatnot. No user serviceable parts inside. Tampering could cause release of hot liquid. Phrasing. Okay, so there's a couple screws here. Oh man. This holds the Rad and pretty much everything down to this big aluminum plate. So this should be the one that gets the most destruction, so to speak. Wow. It's like they didn't even thread these. Oh, it's got... There's like aluminum trapped in the threads. I don't know if that's intentional or what. Nope, they're hammering again next door. Man, I've been off all week on vacation, and I'm trying to shoot as many teardown videos as I can since I'm on vacation. And of course, it seems like every neighbor I have is doing construction. Oh, we're leaking a lot of the pink stuff now. Okay. So there's a screw in here holding this mystery black piece together. I mean, I'm guessing it's a reservoir. Okay, so that's still connected. Since they're still hammering away, I took the opportunity to do some cleaning and drying, and like there's still coolant in the Rad, so I managed to get a lot of that out. This is one of the two side brackets that hold the whole Rad unit upright. And you can see the cutouts for all the copper loops that allow the coolant to zigzag through the gigantic Rad. I mean, this is a really, really nice Rad unit. Beautiful. They just don't make them like this anymore, do they? At least not for computers. There's a little bit more of the... See if I can get some more out. Yeah. It might almost be done. Now there's coolant all along here. See, there's a couple spots where it's dried. Now, I do not know if that is recent or if this unit was actually starting to leak. I simply don't know. I mean, it looks kind of crusty, so I assume it's kind of old, but I don't know how quickly this stuff dries. For all I know, this was just spilled on it last night and it just hardened. Oh, the cats are getting frightened from the construction workers. Anyway, yeah, beautiful unit. Look at that. All the copper connections. So that is the Rad unit. That is what allows the transferred liquid to cool and then get cycled through again. So let's get this out of the way and take a look at the pump arrangement. Now these probably still have a little bit left in them. So the basic arrangement of this unit was that these two are interconnected like that. So it flows out of one into the other. And then they flow into this thing, which, like I said, I think is just a reservoir. Now I don't see any screws or anything on it, but there are a couple hoses still on it. Now this is the clamping mechanism. They have these very nice metal spring clamps on it. You squeeze them and it releases it. Oh, there's a little fruit fly buzzing around. I don't know how well that shows up in HD, but it's there. And they pull off, and as you can see, there's no O-rings. So I guess only the early one had O-rings, but anyway, yeah, you squeeze and it's very easy to put on, and it tightens right up. Very nice design. Let's just get all of these guys off to make things easier to work with, and it will also probably help it drain a bit better if there's any left in here, which I imagine there is. Yeah, I hear, oh, that's just water, because I was trying to flush it with water, because just figured that was a good idea when I was doing it. So how can we get into this guy? Looks like there's a seam along here. Let me grab, let's try this guy. I don't think this is going to work, and I'll probably injure myself, but let's just see if... Yeah, that's really tough. I guess it has to be, but I think what we'll do is we'll leave this for last. I may have to take this out into the backyard and beat the crap out of it. We'll see, but let's get one of these pumps disassembled. So there's two of these, and they appear to be identical. They use a 4-wire interface, and it's kind of a strange interface. I was thinking it was a standard ground plus 12-volt tachometer and PWM arrangement, but apparently it's like this funky, like I think one of them is tach, but it's also like a plus voltage for speed control. So you need 12 volts on 2 different lines. Okay, this is spring-loaded. It's interesting. I don't think I've ever seen a spring in one of these before. It's a good thing I was taking these off slowly. I wonder what these springs are for. That's very weird. I don't know what these... I mean, they're not holding it down. Interesting. Okay, so there's these metal brackets holding this down. Huh. That is bizarre. Okay, so the whole unit is... Actually, that's very brilliant. The whole unit is... it has springs. So here's what's happening. The CPU is right here, right? There's screws that go up through the CPU into these holes, and then they're sprung. So you're running the screws into this. I mean, these aren't the right kind of screws, but you get the idea. You're running the screws into this, and because it's under tension, it has some give, and the whole thing can just adjust to be perfectly flat. That's really smart. I like that. Wasn't sure what that was for. It's most let me get some paper towel since we have some spillage here. Oh, stuff's getting everywhere. Oh, cool! And it appears to stain anti-static mask. Let's get some alcohol on that. See if that. Nah, that might just be pink forever. Oh well. It's not like there aren't any 800 other marks on this thing. So let's take a look at how the actual water block works. Now, where did I put my little screwdriver? Too many screwdrivers? Oh, there it is. So these are the screws that actually hold the copper plate. Now, what I expect to find is a channel that the cooler liquid is injected into, and then it zigzags over the hot spot of the copper, thus giving it the most surface area, allowing it to absorb as much heat as possible. Remember, you only absorb heat, you don't give cold. There's no such thing as adding cold to something. You take heat. And last one. This looks very familiar, just like I have an H100 and a couple H60s from Corsair. They look very similar. They're pre-built coolers. Oh. Oh, that's really interesting. I've never seen one like that. Wow. Huh. So, here's the impeller. I think it's an impeller. Drain some of that out. So, wow. Okay, now, if I recall, is this the inlet? I can't remember now. No, this is the inlet, I believe. So the liquid comes in and is sprayed. Oh, this spins too? That is bizarre. Is this just like always spinning to give it, to allow it to, oh no, okay, so this is actually locked in place. Okay, I see how this is set up. So this isn't locked in one position. So this must be the inlet. So the liquid is sprayed in and then just bounced around all of these little pits to just distribute it. And this is actually fairly heavy copper right here. And there are a couple O-rings on this. Although, as far as I know, this doesn't leak. So there's 2 O-rings on that. Yeah, we've got the liquid spraying in and it's absorbing all the heat from these little posts that are sticking up. And you got little divots to give it even more surface area. And you got this impeller just spinning around like crazy, basically sucking it up and spraying it out one side. Now, I don't know if we can get any deeper into this thing? Let's find out. Okay, so here's the control board. Oh, and this came out. These are often just magnetically held in place. Now, this is all potted. Although it seems like it's kind of a flexible potting compound. Let's see if we can do some drastic surgery on this. It's good that they pot it. Potting keeps it from getting damaged by moisture. Now I've read the cooling units on this, or the actual motors use the liquid as cooling for themselves, so you shouldn't run it without liquid in it. But the way these are usually set up is that they don't actually physically come in contact with the actual blades. These are usually held in by a magnet, and then just a magnetic field transfers that over so that it's completely sealed. But I don't know, this might be an older setup. Now, what is the purpose of this gear here? That just seems weird. Let's see if we can. I guess it is attached. I guess it's just an older design where they do physically attach this. Oh, there is a little bearing that seems to kind of move. Oh, part of it came off. This is a cheap knife, so I don't want to hear any complaining that I'm ruining my knife. So this does pop out a bit. I think I just have to fight the magnet. There. Yeah, magnet. Okay, so does this turn? Doesn't. Oh, maybe it does turn. Yeah, okay, so this turns, but I don't think this is actually. This is just a guiding post. This is just holding it in place yeah, this is a separate sealed system. So what's happening is, dry this off a little bit. This is a permanent magnet, as you can tell, and in here you can see, just peeking through the goop, there's a permanent an electromagnetic coil. So what it's doing is it's inducing a magnetic field in series to spin this without physically contacting it. That's how they're able to maintain a complete separation from the electronics. And it's weird that this post does go all the way through. You'd think that they would just intentionally keep it short enough that it doesn't penetrate into the dry area. But I guess it's good enough. Let me see if this pops off now. It crumbles. I wonder if I can pry the whole thing out now, that there's no more post. Maybe not. Looks like there's a fairly large IC in there. I don't know if it's large for power delivery or it's large because there's actually like some high degree of logic in it. I assume it's large because it's a motor driver, but I don't. It looks like it's impossible to read the numbers off it while it's in here, so we may never know. Okay, well, this is coming off now. It comes off in like little chunks. Looks like, oh, I might be able to read it actually. I might have to pause it and take a look at it under magnifier, just because on a weird angle I can't really read it off the screen if it's showing up. I think the motor is soldered in, so I'm not going to bother desoldering this because it's going to burn all the potting compound and smell pretty awful. But there's quite a bit in here. A bunch of resistors, a little 4-pin device. That's probably a magnetic sensor for the speed. Alright, I'm going to try and read that number. Alright, I did a little bit of searching around and I figured out what this is. This is a Sanyo made LB11861. It's a PWM controller for, let me just find the product descriptor. Direct PWM variable speed fan motor driver IC developed. Yeah, okay. Easily implements variable speed control of PC cooling fan, cooling water pump motors, and can also be used in fuel and air pumps in fuel cells. Alright, way to go, Sanyo. Yeah, so this is up to 15 volt, blah blah blah, 1.5 amp. It runs at 16 to 50 kilohertz. And it comes in a bunch of different packages, blah, blah, blah. It's kind of a boring data sheet. Doesn't even have an example. Oh well, that's where that's what's controlling it. These things will be, of course, identical. And the last thing on the list is figuring out what's inside this thing. After some moderate dremeling, I managed to get this thing partially open. This thing is really tough. It's very thick, heavy-duty plastic. In fact, if you see, I tried to get through on this side and it was just really thick. It's actually just melting into a blob. It's very tough. And yeah, I don't know if you can see in there, but yeah, it's just a reservoir. Nothing's going on in there. I didn't think there really would be. There's nothing, not like there's any electronic lines running into it, no power or anything. But yeah, I mean, it's very tough. So, and from what I can tell, it's one chamber. So I guess this is also just balancing it or something. Not 100% sure. But yeah, it might all have to do with just balancing the flow and just having a big reservoir for it to move around. Because you'd think it would be running liquid through the CPUs into the... Excuse me. Of course it's a damn telemarketer. Well, it's a telemarketer based on my Google search, seeing as when I picked up it was just dead silence. Oh well. Anyway, based on what I've seen here, I would say that this thing's actually very well built. Now, there is the chance that there's some problem with their welding technique because, like I said, I've got corrosion here and here. Assuming this is just nothing and it's just something that, you know, showed up in the last day or two, I would say that this is actually very well made. Now, one thing to note is that this side's very dirty. The copper, it looks like it's been, you know, heavily oxidized, whereas this side is nice and clean. So it is possible this was some kind of leak and affecting it. But based on just the build quality, like you know, the block, how heavy it is, just the quality of the pipes, the fact that there's no O-rings on anything except for this, which is normally basically have to have that. You know, these clamps are very well made, and they've double clamped pretty much everything for just, you know, back up. And oh god, that's tough. I wanted to separate it for recycling. So, you know, I would say that this thing's actually very well built. I'd like to get my hands on one of the earlier liquid cooling units, the ones that are like known defective, and just look at the differences. My guess is everything's got an O-ring on it, and just they all just wear out. But yeah, I have to give Apple a thumbs up for this one. It's very nice, very heavy duty.